All right, guys, today's lesson is the continuation from yesterday, arithmetic sequences as linear functions. So if we recall from yesterday, our equation follows the form a sub n equals a sub 1 plus n minus 1 times d, where n is a counting number, just meaning that counting numbers are 1, 2, 3, 4, and so forth. So I'm not even going to do the example with you. Well, I'm gonna quickly do the example. There are 20 seats in the first row of the balcony of the auditorium. There are 22 seats in the second row and 24 seats in the third row. So the first thing we want to do is we want to write this out in order. So 20, 22, 24. The first term, a sub 1, is 20, and then we're going to find the common difference. So we're adding 2 to each one. So the common difference, d, is 2. So then we plug it into our formula that we did yesterday, a sub n. A sub 1 was 20, and d is 2. And then when we distribute the 2 in, we get 2n minus 2. So 20 minus 2 is 18. 18 plus 2n, and that is our function. Now, the next thing they wanted us to do was graph the rate of changes to make a table and plot points. So when n equaled 1, a sub 1 was 20, so they plotted that point, 1 comma 20, 2 comma 22, 3 24, and then 4 26, and then you're just plotting your line through it. So we're going to go ahead and look at the first example. Sarah learns to knit from her grandmother. 2 days ago, she measured the length of the scarf she is knitting to be 13 inches. So I'm going to underline the lengths. Yesterday, she measured the length of the scarf to be 15.5 inches, and today it measures 18 inches. Write a function to represent the arithmetic sequence. So the first thing we're going to do, we're going to put these in order. First day, day 1, was 13, then it was 15.5, and then it was 18 inches. And we're going to see what the common difference is. So to get from 13 to 15.5, you add 2.5. And then we're going to see what happens when I add 2.5 to 15.5. I get 18. So that tells me that d, my common difference, equals 2.5, and a sub 1 is our first term, which was 13. So now I can write my formula. A sub n equals a sub 1 plus, parentheses, n minus 1 times d. So when I plug in what I know, I get a sub n equals, a sub 1 is 13 plus n minus 1 times d, and my difference is 2.5. So I'm going to distribute the 2.5, so I get 13 plus 2.5n minus 2.5. So 13 minus 2.5 is 10.5 plus 2.5n. I can leave it like that, or I can change it. I like putting my variable first, so I'll change it to 2.5n plus 10.5, and that's a sub n. Now let's look at the second one. Refreshments. You agree to pour water into cups for the booster club at a football game. The pitcher contains 64 ounces of water when you begin. After you fill 8 cups, the pitcher is empty and must be refilled. So, first thing we want to do is we want to notice that it contains 64 ounces of water. So we're going to start with 64 ounces, but then when we pour 8 cups, it's completely empty. So I'm going to divide 64 divided by 8, and that's going to give me my common difference. And 64 divided by 8 is 8. And that is going to be known as our common difference. Now, here's where it gets a little tricky. All right? All we need is our difference and a sub 1 to write our formula. But what does a sub 1 actually equal? It would be a mistake to say a sub 1 equals 64, because 64 means that there have been no cups filled. So a sub 1 is actually going to be 64 ounces minus 8, because that's what our common difference is. So our common difference was -8, by the way. So 64 minus 8 is 56, and that is what a sub 1 is. So now I know a sub 1 and I know d, so I'm going to write my equation. A sub 1 equals, or a sub n, I'm sorry, a sub n equals 56 plus n minus 1 times d, and d is -8. So then when I plug in, I distribute the -8 in, I get 56 minus 8n plus 8, which simplifies as, I'm going to put -8n first, plus 64. And if you remember, that looks like the equation of a line. So my slope is -8, and my y-intercept is 64. So now I can go over here and just plot these points. My y-intercept, when x equals 0, y equals 64. And then my slope is, I'm going down 8 for every cup. So I'm just going, 1 cup would be 56, 2 cups would be 48, and so forth. 3 is 40, and you see our line. And it should match up. At 8 cups, we're empty again, so it should, and it worked out perfect. So that's it. That's our work for today. Make sure you submit your work. Have a good one, guys.